of life is a journey. Which paths we take, which we look back on, and what we look forward to is up to us. We determine our destination. Human beings begin their journeys in life the minute they start walking. Since the 1400s, humans have set out across the world and 7 seas, mostly to explore new beginnings and opportunities. This was the start of navigation. Navigation is both a skill and an art, the basis of which is proper planning, from the rocks and moons to satellites in space orbits. With time, navigational techniques have kept getting more accurate and easier for the traveler. Take, for instance, the aviation industry. It is said, life is one big journey, and billions of people around the world embark on air trips that take them miles away from home. Have you ever wondered how pilots know where to go or what paths to follow? With the development of the Global Positioning System, GPS, aerial navigation was made much easier, as this satellite navigation system was designed to provide instantaneous position and time information anywhere in the world. Hence, there was a need for better technological advancement. In India, the management of airspace is the function of the Airports Authority of India, who along with the Indian Space Research Organization met this need for a better technological advancement and implemented a satellite-based augmentation system that would provide signals for improving accuracy, availability, continuity, and integrity of GPS signals. This advanced technology is known as Gagan, GPS-aided Geo-augmented navigation. It consists of 3 segments, which make up the space-based augmentation system. S-bars. They are the ground network segment, the space segment, and the user segment. The ground network segment consists of reference stations, the master control center, and an uplink Earth station, while the space segment consists of the GEO and GPS satellites, forming the geostationary space segment.
GSAT-8 carries a Gagan payload, also meant for satellite-based augmentation of GPS signals over India, for use by the Airports Authority of India. The entire design, development, realization, integration, simulation and testing of GSAT-8 is a testimony to India's technological maturity in this area. The development and testing of payload for GSAT-8 was carried out at Space Application Center of ISRO, and final integration of the payload with the satellite bus along with the satellite level testing was performed at ISRO Satellite Center. ISRO's satellite launch vehicles are capable to launch 1-ton and 2-ton category satellites from Satish Dhawan Space Center, Shahar, the spaceport of India. The new multi-purpose satellite, GSAT-8, is weighing more than 3 tons. This is one of the largest and heaviest satellites which ISRO has developed till date. The GSAT-8 satellite was airlifted from Bangalore to French Guyana, Kourou, for its launch on board Ariane 5. At French Guyana Spaceport, GSAT-8 successfully underwent the spacecraft level checkout operations before its final integration to the launch vehicle.
The user segment consists of the aviation industry and any other user having S-bus compatible receivers.
The GPS-aided Geo-augmented navigation system, popularly called as Gagan, is a planned implementation of satellite-based navigation system being jointly developed by Airports Authority of India and ISRO. This is to deploy a certified S-bus system in Indian FIR with a potential for its expansion to neighboring airspace. When commissioned, Gagan will provide civil aeronautical signal consistent with ICAO's SAPs. ICAO has already endorsed Global Satellite Navigation System as a future navigation system.
With a state-of-the-art master control center operating in Bengaluru, a watchful eye is maintained over the entire system. How does Gagan work? Well, the Global Navigation Satellite System, GNSS, data is received and processed at widely dispersed Indian reference stations, INRES, which are strategically located to provide coverage over the required service volume. Data is forwarded to the Indian Master Control Center, INMCC, which process the data from multiple INRES to determine the differential corrections and residual errors for each monitored satellite and for each predetermined ionospheric grid point, IGP. Information from INMCC is sent to the Indian Land Uplink Station, INLAS, and uplinked along the geo-navigation message to the Gagan GEO satellite. The Gagan GEO satellite downlinks this data to the users via two L-band ranging signal frequencies with GPS-type modulation. Gagan provides less than 3 meters accuracy for aircraft navigation and precision approach up to Category 1. Reference stations have been set up and widely spread throughout the Indian territory. There are 15 reference stations located at strategic locations like Ahmedabad, Bengaluru, Delhi, Guwahati, Jammu, Kolkata, Port Blair, Trivandrum and various other stations, with the Master Control Station and Uplink Station located in Bengaluru and Delhi. Gagan coverage area expands from Australia to South Africa. With the implementation of the Gagan system, the satellite navigation system will become the primary means of navigation in aviation. The Gagan system will significantly improve efficiency in the civil aviation sector by shortening routes, thus increasing fuel efficiency. The commission of Gagan will help in gradual phasing out of terrestrial navigation aids, thus reducing workload of air control tower officers as well as save on costs. It will provide accurate and precise data that will help in greater runway approach capability. Deficiency in service will be notified within 6 seconds, which will improve safety. Gagan will provide greater and safer access to planes in all weather conditions. With the aid of Gagan, navigation will be made easier and safer at airports situated in difficult terrains. Gagan will be of great use in geographical terrains where traditional navigation aids are impractical to install. Gagan will provide Category 1 precision approach service level to aircrafts. With higher accuracy and global coverage, it will play an important role in upper airspace management. The scientific community can put this system to good use for surveys, geographical mapping, marine navigation, atmospheric studies and geodynamic studies. This advanced technology will greatly benefit India and its people. The way we connect, communicate and commute will change significantly. Gagan is a project of national and strategic importance. The total project cost of Gagan is 774 crores. And with the implementation of this system, India will be on the global radar of every harbour, land strip and airport. Gagan will become India's eye in the sky. Gagan, redefining navigation.